Hello students, welcome back. How are you all? I hope you're all fine. Okay, so let's today start with a new chapter. The name of this chapter is Area of Parallelogram and Triangles. We have learnt about the areas of parallelogram and triangles in previous classes too. So what is new in this chapter? So in this particular chapter, we are going to find out about the relationship between the area of a triangle and a parallelogram, and between even two parallelograms when they are having a same base and they are between the same parallels. Okay, so just first you have to answer that what is area? What do you understand by the term area? What is area? Area is nothing but a region enclosed by a figure. If I am drawing these four lines, then these four lines are making this particular region. So this particular region in numbers, okay, and having some units will be known as what? The area of this region. Okay, you got that? Okay. So basically, we know about the figures triangles and parallelogram. What are the triangles? We are having 3 points, okay, and then we meet them. Let's suppose 3 points were what? P, Q and R. So when we'll meet these 3 line segments, we'll be having these 3 angles. So this is that is 3 angles we are having. All are three sides we are having 3 vertices, okay, and we are having 3 angles. So this is about a triangle. Now what is a parallelogram? Okay, if I'm having a quadrilateral such that the opposite sides are equal to each other, also they are parallel to each other. Okay, so if I'm talking about this first and second side, these are to what? Equal to each other and parallel to each other. And then 3 and 4 are also equal to each other and parallel to each other. Okay, so now what we will do, we will study about different categories of having same base or having same parallels, okay, or both. And we'll study about what is the difference of what is the specific, what is the speciality when it comes that they're having a same base and they are between these same parallels. We are talking about only triangle and the parallelogram here. Okay. So in this figure, you can say that if this is point A, this is point B, this is point C and this is point D, then what is showing here that this AB is the base. What? This AB is what? The base. So we are having the same base or a common base. Okay. So if I draw a line here, so this point C and D, okay, I'm making a line segment CD, and this CD is clearly not parallel to AB. Okay. So they are having same base but not parallel, but not between the same parallels. Now here we are having this A, B, C, D and E points. Clearly, if this is a quadrilateral and this is a triangle, this triangle and quadrilateral are having the same base AB. Okay, this is the only thing we are having here, that the base of these diagrams are what? Same. Okay. Then try to understand these figures now, and now you can look at it and tell me what is the difference between these figures and the previous ones. Okay. Okay. As we'll talk about this first diagram, here we are having this AB line segment, this CD line segment. You can clearly see that this AB is parallel to the CD here. Okay. Now you can also see that we are having this parallelogram here. This parallelogram, if this is E and this is F, then we are having this ABGE parallelogram here. Okay. And we are having this ACF FB, a quadrilateral here. Okay, surely between the same base AB. So, same base is what? AB. Now, we will talk about this. Here we have got these points A, B, C and D. Okay, so look at it. We are having the same base, common base AB. And these two triangles, this first triangle and the second triangle, these two triangles are between what? Same parallels. We are having CD parallel to AB or AB parallel to CD. So here in this stage, what we are having? We are having two triangles between two parallels and having the same base, which is AB here. So in our further lectures, we'll find out that there is a relation between this area and this area. That means there is some relation between the areas of these two triangles. Okay. Now, we have, talked enough about this. Okay. And we'll do some exercise. Which of the following figures lie on the same base and between the same parallels? In such a case, write the common base and the two parallels. What we will going to do here, okay, we are just going to look on the figures which are given to us, and then we have to tell that the common base, first thing, okay, and first we have to find whether they are on the same base and between the same parallel. And if yes it is, then after that we are going to find out that what is the common base and what are the two parallels, right? Okay. So, have a look on the figures. These are the figures, okay, and quickly I am going to name them. A, B, C, D and E. Here we are having this base AB, C, D, E and F. Here I am having this A, B, C, D and this E. Similarly, I'll be having this A, B, C and D, and let's suppose this is the diagram. Okay, so four diagram basically we are having here. Now we have to tell about the first, second, third, fourth. We can mark here. So, okay, I am writing the parameters for the first one. For the rest, second, third and fourth, you will write down all by your own. Okay. So, the first thing. Now, we are having this common base AB. Look at this diagram. We are having this triangle ABE. Okay. And this parallelogram, not parallelogram, but the quadrilateral. Right. So, this quadrilateral ADCB or ABCD is having what? A common base AB. Okay. So, we can write for the first that for the first we can write that AB is the common base. First, that yes, they are having the common base and they are between the same parallels. Okay, AB is the common base and triangle ABC and quadrilateral ABCD are between the same parallels and what are these parallels? First, the common base AB and second, the DC. Clear? Okay. Then, if we talk about this second number, okay, they are both having this parallelogram ABDC and this quadrilateral ABFE. Okay, these are having the same base AB, but not the between the same parallels, because here AB and EF, let's suppose they are, if this is trapezium, then this EF and AB are parallel. Okay, and the CD and AB are also parallel, but neither of these two figures are are between the same parallel. That means they are nothing like a pair of lines, of parallel lines that are having these two figures in common. Vertices of this quadrilateral are not on this line CD, or neither of that on this line EF. So we are having this common base AB, but we are not having these in the same parallel. Okay, if we talk about the third one, we are having this triangle here, and then we are having this parallelogram here. Here again we are having them, we are having the same base here, which is AB again, but the ABE triangle and ABCD, the parallelogram, are not having again between the same parallels. So they are not having same parallels, but having the same base AB. Now if we talk about this ACB, okay, this triangle ACB and this parallelogram ABCD are having the same base AB and are between the same parallels AB and DC. Okay, here AB is parallel to DC. Alright, okay. Okay, so if we talk about these figures, we can also name them like A, not by this. Okay, so we can name them like A, B, C, D. Okay, and this is E. Here what we'll say that this ECB and this ABCD, parallelogram ABCD and the triangle BCE, these are having the same base BC, and also they are between the same parallels AD and BC. It's not always necessary that you have to look figures like this only. Okay, this is the base and these will be the two parallels. Base can be that also, base can be that also, base can be that also, and that base can be that also. Okay, so we are having this common base BC here, this base, okay, and we are having these two parallels AD and BC. Okay, now similarly if we talk about this figure, in this figure what we are having now, have a look here. This is A, this is B, this is C, this is D, this is E, F, G. Now we are having here this triangle which is FGE and this parallelogram which is ABCD. Now these are having, okay, these are between the same parallel lines CD and AB, okay. This is between the same line, same parallels AB and CD. But what is happening here, that this triangle is having FG as its base, not AB as its base. Though they are on the same line, but the base is not same. The base of parallelogram is AB and the base of the triangle is FG. So there is a difference. So yes, they are not having any common base. Okay. If the fraction of the line is common between them, it will not work. Okay, so they are not going to be on the same base, but they are between the same parallels. So these are the conditions that can arise when you will be solving these kind of questions. Okay, so this is just kind of, like introductory part questions. Okay, okay. Now, parallelograms of the same base and between the same parallels are equal in area. What is the theorem here we are having? Parallelograms on the same base and between the same parallels are equal in area. Okay, what is this about? If we are having this line, these are having these points, okay. And we are having this parallelogram ABCD. Now what we'll do, we'll be having a distance AE and we'll be having this A is equals to this BF and we'll meet them. So by this, what we are making, this EF is equals to this AB. That means again this EF is equals to this DC, and here AB is also equals to DC. This line is parallel to DC. This AF line is parallel to DC. So the part of these lines will also be parallel. That means EF is also parallel to DC. So basically we are having here ABCD is a parallelogram, and this D, E, F and C, this is also a parallelogram. In this condition, the area of this parallelogram will be what? Will be equals to the area of this parallelogram. These areas will be equal, or what we can say that area A, B, C, D is equals to area E, B, C, D. This is what we are going to prove. Okay, we will prove that, this particular theorem in our next lecture. But before that, because we are having some basic area knowledge for the parallelogram and triangle, so we are just going to see that now. Okay, so here it comes. If you talk about a triangle ABC, so here we are having a triangle ABC. Okay, and let's suppose I'm having the medians of these triangle. Okay, what is the median? If I locate the midpoint of AC as D, okay, and we'll meet at the opposite vertex, that is BD, then BD is median of AC. Why is it so? Because this BD is dividing this AC in two equal halves in this AC line segment. Similarly, I can locate a point E here, okay, which will divide this AB in two equal parts, okay, and that will be the median. Similarly, I can have a point here as F, which will divide BC into two equal halves, and I'll join them. Now, these are the median. First, we'll be getting knowledge about the median. Why we are getting knowledge about the median? Because we'll be using them. Okay. Now, if I'm having this another triangle A, B, C, okay, or we can just use that particular. Now we are not going to make any halves of the sides. Then what we are supposed to do? Okay. What we are doing, we are having this triangle, and now I am going to have a perpendicular to this line AC, okay, and from the point B. So this is the perpendicular, I'll name it D. Similarly, I can have a perpendicular to AB from this vertex C, and I'll name it E. And similarly, I'll draw a perpendicular from this point A to BC and name it E. Okay, and they'll coincide in the same way. Now, what if I have to find the area of this triangle? Okay, the area of this triangle, area of triangle ABC is equals to half multiply by base multiply by height, or we can say that half of the base and half of the product of base and the altitude. Not what is altitude, the perpendicular distance. If I'm taking this AC as base, so that will going to make it half multiplied by base, which is AC. Now if AC is base, then BD is going to be the altitude or the perpendicular. Okay, so if I'm taking this base AB, I have to take this as altitude. Okay, if I'm going to take BC as base, I'll be going to take AE as altitude. Okay, and if I'm going to take AB as base, then I'm going to take EC as altitude. Now, this should be very clear to you guys, okay? No any kind of doubts in mind. Now, AC is completed, I'll be talking about AB. AB, in that case, we are going to have this altitude EC. Similarly, that will be also equals to half multiplied by CB this time, CB, and the altitude will be AE. So this is how you will be finding out the area of triangle. Now what about the area of parallelogram, students? We are not going to leave parallelogram like this. Okay, so just first make a parallelogram here. Let's suppose if A, B, C, D a parallelogram, that means that CD is equals to AB and AD is equals to BC. Okay, now area of parallelogram is equals to what? Area of parallelogram is equals to base multiplied by altitude. Okay, okay. Then if I'm having this base AB and I'll be drawing a perpendicular here, right? A perpendicular here. Let's suppose this is E and this is F. So I'll be multiplying this EF to AB, and here that will be my area of this parallelogram. Okay, so in this particular lecture, you have talked about the area, what basically the area is, and then we talked about the triangle and parallelogram between in same base and between the same parallels, or maybe not between the same parallels but having the same base, or maybe between the same parallels but not having the same base. Okay, these kind of conditions we have considered, and we have gone through some questions of that, and finally we realized we are having something like areas. We have to know the areas of parallelogram and triangle, and then we have a look on the medians of triangle also. Okay, and somehow we find out what the area is of parallelogram and triangle. Now, in the next session, we are going to prove, in the next class, we are going to prove that if we are having these two parallels, AB and CD, okay, and we are having the same base, let's suppose this AB and same base, okay, and I'm drawing another parallelogram over there, which is also between the same parallels and having the same base, then the area of this parallelogram will be equals to area of this previous parallelogram. This we are going to prove in the next lecture. So till then, study hard, students. Take good care of yourself, and bye-bye.